Some problems that you would normally do with long division can be done with something called synthetic division. And this is when you're dividing a polynomial by a polynomial, but especially when you're doing it by a binomial that does not have a number in front of the x. In other words, the coefficient is 1. So when that happens, then this lends itself well to the synthetic division shortcut that we're about to learn. And so what you do is you think about this factor right here, or this binomial. We've learned that if you were to set that equal to 0, if that were a factor, the 0 of the function, or the x-intercept, would be positive 1. When it looks like negative 1 as a factor, it looks like positive 1 as a 0 of the function, or as a x-intercept of the function. And because of that opposite thing that happens, then what we're going to do is we're always going to put what we call the 0 in there, and that's the thing that would make the binomial equal to 0. And so just always put the opposite of whatever you see there in this little box. Then the next thing you do is you write just the coefficients of all this polynomial down, but you've got to be careful to have a placeholder. I didn't show you this in long division, but in long division, if there was a term missing, you would have to put a 0 there to kind of hold that spot. And so if you have x to the 4th and x to the 3rd, you have to have 0x to the 2nd to hold that spot in between there, because we don't have an x to the 2nd term. Then we have an x to the 1st term, which is good, and we have our no x term, which is good. And so you need one of everything, and if there's something missing, you'll have to put something like this to hold the spot in between the two. Otherwise, that whole thing where they line up vertically won't happen. Everything will get offline if you don't have a placeholder spot. So because of that fact, it also happens that way in synthetic division. You're going to have to put a 4 and then a positive 2, and then you're going to have to squeeze in a 0 there for the x squared spot, and then the coefficient of x is like a 1, and so you're going to put a positive 1 there, and then you want to treat this like a negative 3, even though it's minus 3. If you add the opposite, it would be a negative 3 anyway, so the coefficient is considered to be negative 3. Then you leave some space in here, and you draw a line down here, and then you always bring down the first term just as it is. You don't do anything with the first term, you just bring it down below the line. Then the process is multiply, add, multiply, add, multiply, add. So we're going to multiply 1 times 4 and get 4. Then we're going to add down. You don't subtract, you add down. Then you multiply 1 times 6, put the answer here, and add down. Then you multiply 1 times the next 6, put the answer here, and add down. And then you do 1 times 7 is 7, and add down. This set of numbers down here is your quotient and your remainder, and this is how it always plays out. I always box off the last number, and that is my remainder. So that one's always the remainder. Then the very next one is what we call the constant. In other words, the one that has x to the 0, so the x went away, and so it's just a constant number with no x. Then the next one will be x to the 1st power, the next one will be x to the 2nd power, and the next one will be x to the 3rd power. So that's how it always plays out, is remainder from right to left, remainder, constant, x to the 1st, x to the 2nd, x to the 3rd, until you don't have any more terms. So the way that looks as an answer is the division of this polynomial by this little polynomial, a binomial, equals 4x to the 3rd, so we'll write that 4x to the 3rd, plus 6x squared, since it's positive, plus 6x squared, plus 6x plus 7 with a remainder of 4. If you're asked for just a remainder and there's just a blank box for the remainder, then you would just put 4. But if you're supposed to write the polynomial as a whole, you'll put plus, and then I can't quite fit it here, but you'll put plus 4 over, and then look for what your divisor was. It was x minus 1. So x minus 1. So you would normally put those side by side, but I ran out of space. So this whole thing, including adding the remainder on the end, is the answer to this division problem. So here's another example. Another way that you could write a polynomial divided by another polynomial is to put it over. I just wanted to show you a different form. And this is considered the divisor. I sometimes use the phrase bottom out. The bottom thing goes on the outside of the division bar. And then we write the dividend all underneath here. But to do this, because the x doesn't have a number in front of it, and this is a binomial, we can do the shortcut, which is the synthetic division. So remember, we want to put the opposite of whatever you see next to the x, put the opposite sign in the little box. Then you put your 1 coefficient, your -5 coefficient, your 5, your +7, and your -12. And notice here that x to the 4th goes down to x to the 3rd, goes down to x to the 2nd, x to the 1st, and then x to the 0, which is no x, and we leave it off. But those are all there, and so we didn't have to have a 0 placeholder on this one. So then we draw a line with some space in between. We drop down the first guy. We do 4 times 1 and put the answer here. Add down. 4 times -1, put the answer here. Add down. 4 times +1, put the answer here. Add down. And 4 times +11 is 44, and add down. Remember, this guy then is the remainder, and then you've got your constant, your x to the 1st power, your x to the 2nd power, and your x to the 3rd power. So let's write the final polynomial. So we put 1x to the 3rd minus 1x to the 2nd plus 1x to the 1st plus the constant, which is 11, or x to the 0, which we don't have to write. Then we put the remainder as plus that remainder number over the divisor, and if you go look at the divisor, it was x minus 4. Now some of these extra ones are unnecessary, so you could write this one as x to the 3rd. This one is just minus x squared. This one is just x. This one is 11, and then 32 over x minus 4. So that would be the best way to write it.